Hi, everybody. Welcome to the October 8th live call with Public Lab. And we're very happy to have Daniel Sarowitz and Philip Silva with us today. The purpose of this call is to follow up on some topics that were raised during the September Open Hour on transparency in environmental data and environmental policy. What was interesting about that day that we discussed that in September was that the very same day, Daniel Sarowitz, who is here with us, published a column in the journal Nature with some very interesting perspectives about this that I'm excited for him to share. And then when I realized that Phil Silva would also be available, this opportunity really came together. So thanks everyone for watching. Let me briefly read the bios for both Daniel and Philip, and then I'll hand it over to them for a brief overview and then hopefully an interactive discussion in the last half an hour. So Daniel Sarowitz is on the faculty of Arizona State University, where he co-directs the Consortium for Science, Policy, and Outcomes, which he co-founded in 1998. His work explores the relationships among knowledge, uncertainty, disagreement, policy, and social outcomes, he thinks. His most recent book is The Techno-Human Condition, co-authored with Braden Allenby, came out on MIT Press in 2011, and he edits the magazine Issues in Science and Technology as a regular columnist for the journal Nature. He is about to start a cool new project on harmonies between science and religion. He used to be a geologist and also worked as a congressional staffer. Philip Silva is an environmental planner, advocate, and educator producing a PhD in natural resources at Cornell University. Philip is the co-founder of TreeKit, an initiative helping city dwellers measure, map, and collaboratively manage urban forests. He also works with Farming Concrete on efforts to help community gardeners throughout the world measure the good things happening in their gardens. He is a regular contributor to The Nature of Cities, a website publishing original content on cities as ecological spaces. Philip has worked with many of New York City's most celebrated environmental stewardship organizations, including Sustainable South Bronx, the Southern Bronx River Watershed Alliance, Brooklyn Botanic Garden, Just Food, New York Restoration Project, Gowanus Canal Conservancy, and Trees New York. He is a senior fellow of the Environmental Leadership Program and a certified practitioner of dialogue education. So we're really excited to have Daniel and Philip with us here today, and I'm going to just hand it over to Daniel to get us started. Thank you.
Okay, thanks, Liz. And I should just characterize us differently. I'm the hapless academic, and Philip actually does things. So, so let me say a little about this Nature column, why I wrote it, what I was getting at, and then turn it over to the person who does things. I mean, I think the large-scale context for this is my increasing conviction that kind of the science system, whatever that is in deep trouble, which is maybe a way of saying, you know, I hope this doesn't sound too academic, but kind of the whole sort of modern project, right? Rationality driven by facts to make better decisions and lead to progress in the world is also kind of coming undone. The column is about what I think is a really interesting example of one manifestation of this, right? So if you all are kind of a science watcher, one thing you've noticed in the last 4 or 5 years is that suddenly there's a lot of attention to the idea of replication in science and to some embarrassing revelations that it turns out that a lot of science that is supposed to be reliable and the basis especially for pharmaceutical innovation turns out not to be any good. And to add to the embarrassment that these revelations of lack of replicability don't actually come out of the academic community, they come out of the pharmaceutical industry, which got tired of the fact that 90% of their clinical trials fail. And so they began to start looking at some of the peer-reviewed science that they were basing the trials on and found that they couldn't replicate a very significant percentage of them. So that's led to kind of a I'd almost say a cottage industry focused on the question of is the science we're doing reliable, especially in biomedicine? Is it? How do we know? And why is it that so much of it seems to be unreliable? And the science community itself, hasn't really dodged the issue, although they deal with it in different ways. And one way they've dealt with it is to say, well, this is just science doing its self-correction. But there's been some more extreme interpretations, like the editor of Lancet, who's basically said, looks like not only is half of what we do garbage, we can't tell which half is and isn't. So maybe we're wasting tens of billions of dollars. So that's just biomedical science, where most of this stuff is happening. But if it's true there, why wouldn't it be true elsewhere? So that's kind of the backdrop. And then so part of the the medicine that's prescribed for this is, well, we just need to be a lot more transparent about our work, so that people can actually understand why we did what we do as scientists and how and whether or not we can replicate it. And this all raises the issue of whether replication is really the issue or whether there's something bigger going on. But anyway, that's kind of the focus of a lot of the discussions. And it's sort of a naive view of science, in that the idea that you do an experiment and then it's true if you can replicate it, or at least you have confidence in it that if it's replicatable. That's a kind of a fairly textbook view of science that may or not apply. But a lot of people buy it and buy into it, and that's been the source of a lot of the conversation. So then you get something interesting going on, right? So there's all these calls for transparency, and in fact, I'm looking on another screen here at the rules that over 150 journals have signed on to. These are NIH, National Institutes of Health guidelines for what journals have to have: rigorous statistical analysis, transparency in reporting, okay, and data and material sharing, consideration of refutations. The point being that this whole idea of openness in science and as a value that can help to deal with this problem of reliability has taken hold, at least formally, in some high-level aspects of the scientific community. Okay, so then you get this bill, the Secret Science Bill, right? And this is authored by Republicans on the House Science Committee, the chairman of the House Science Committee, Lawrence Smith. And basically what it says is, okay, any science that's going to be the basis for a environmental regulation from now on, all the data that the science is based on have to be made transparent, so that it can potentially be replicated by outsiders should they desire to do so, as part of the regulatory process. So how does the scientific community and the advocacy community respond to that? It's, oh my God, you can't do that, because that's really just a mischievous attempt to slow down the regulatory process, which it probably is. But what this does is it rubs our noses in the incredible difficulty of, on the one hand, saying our regulations are based on replicable scientific information that's dealt with through that's validated through the peer review process, and on the other hand, recognition of this reliability problem and this lack of replicability problem that's coming out of other fields of science that, in some sense, are much easier to do replicable science in than complex regulatory matters. And so you have this standard of demanding transparency, openness, and replicability on the one hand coming out of conservatives who are concerned about regulation. You have a similar commitment to replication and transparency in other areas of science, but this political inconvenience, right, that's forced organizations like the Union of Concerned Scientists and most scientific societies to oppose this Republican bill on transparency in science. And I think overall, what I wanted to illustrate in the column was the knots we now have to tie ourselves into to try to rescue the scientific enterprise so that it still has legitimacy to back the kinds of things we're interested in doing, like, say, regulating toxic chemicals. And I think we're just really in a fix now, and it's very hard to see what the pathway out of that's going to be.
Sorry, I was just unmuting there.
Great.
And I kind of just feel like saying what Dan said. Yeah, I think knowing that this conversation is really being broadcast to predominantly to the public lab community or to the wider world of folks who dip in and out of public lab, I think that this is useful as a sort of first dip in the water of science and technology studies or social studies of knowledge, because I get the impression sometimes in the work I do around, call it citizen science, public participation, scientific research, civic science, you name it, anything that poses itself as different yet similar to traditional scientific endeavors. There's this feeling of showing up at the party to be told that there's no champagne left, right? That like all of the legitimacy, the assumed legitimacy of the scientific endeavor is now being brought into question. And so a lot of the sort of baseline efforts to legitimize work like the work that's done by so many people in and through public lab, it starts to find itself on just as infirm footing as the the big S scientific endeavor right now, and it's just not ready for that. I mean, big science isn't ready for that, but participatory science or citizen science is definitely showing up, and then I think is a little blindsided by the fact that there really is no sort of textbook, the sort of textbook definition of the scientific method, scientific replicability, et cetera, is really just that. It exists in the textbook, but in fact things are far more complex. And it results in a lot of really strange and challenging and at the same time fruitful conversations about, well, what is science? What is this thing then that we're trying to storm the barricades on? And then it does call into question sort of the ideologies of transparency, I think, that you'll hear different stakeholders align themselves with, either in again a group like Public Lab or any other sort of participatory science initiative that's trying to claim legitimacy. Ultimately, what is the point of transparency? Is it again, is it in order to allow different researchers to replicate what you've already done, which, as we're seeing, is probably not all that possible? Or is it more about sharing, which I think is an important word in this conversation, particularly for public lab? So again, sort of the first thing I said was I think the more that we can sort of have conversations around what science and technology studies has helped us to understand about many different things that call themselves science, many different social practices that call themselves science, the better the sort of participatory community is equipped to arrive at this shaky moment and find its footing, if that's possible.
Well, that's fantastic. Thanks, Phil. I was just jotting your words into the chat room.
Dan, I just want to say,
Daniel,
I think it's incredible. I just wanted to say, I think it's pretty incredible that a piece like this can be published in Nature, which is really, it is a bastion of traditional science, which is probably, I can use another phrase for it, but to welcome this kind of conversation in that kind of publication, I actually think is pretty important, and maybe even a sign of the times about how much we're all having to come to terms with a lot of our assumptions about what this endeavor is. So thanks for pushing the envelope and getting this in there.
Nature's actually been great. I think Nature has been much more adventurous than, say, science has been, and much more willing to really delve into this, which I think is actually a testament to the openness of its editor, Phil Campbell. So, yes, they are still a bastion of traditional science, but they are willing to do some serious questioning in ways that other similar bastions, like, say, the academies, and Science Magazine, AAAS, haven't been able to do. I just wanted to say something about legitimacy, right, and just kind of nail a little more tightly what I think the dilemma is, and see if you agree. And I think a lot of the dilemma is that so much of the agenda around environmentalism, and whatever that means, right, has been staked on the legitimacy of science, the legitimacy of this kind of, I'd say, type A male science, right, the stuff that's done in peer-reviewed journals, and is supposed to be replicable and is supposed to be, the standard of what reliable knowledge ought to be. And as that begins to show very frayed edges, to be, I think, understated about what's going on, it leaves those of us interested in doing things at the local level almost bereft, because it means that the thing that we had been depending on to kind of ground our arguments in something that society could recognize is being yanked out from under us. And this is what I meant when I said it's, I think this is really a threat to the whole kind of modern project, right? And so if we're interested in doing things at the local level, and I mean, I think this goes for the whole regulatory state. I mean, if you look at things like the regulation of toxic chemicals, it's been a failure for 30 years, right? And it's largely been a failure because it turns out that science is simply not a good tool for adjudicating value disputes between, say, the private sector and environmental groups. It's terrible. So where does that leave us?
That's a great point of view. I just want to note that point as a great point. Science is not a good adjudicator between, you said, different values, right. Different environmental values. Yes, let's put a pin in that. Okay, thanks, Daniel.
So this is not a rhetorical question. Where does that leave organizations?
Ron, Daniel's frozen for just a minute. Hold on. Okay, Daniel, you're back.
So at what point did my pontification cut out?
Unfortunately, right after I interrupted you, then the internet also interrupted you.
Okay. So I just wanted to raise this question of where is legitimacy going to come from in making kind of knowledge claims for organizations and movements that want to make a difference at the grassroots level, but have kind of adopted the legitimacy of science as their way of advancing their agendas.
I'd like to kind of call into question that there's a failure of science, and kind of pose the option that there's a failure of politics. I think that that the problems we're seeing are decision-making problems more than they are scientific understanding problems. Do you disagree with that?
Jack, let me introduce you. So this is Jack Summers, professor. Where are you a professor, Jack?
I'm at Western Carolina University. I'm a chemistry professor.
Great, and I know Jack through his work in public lab as a technology developer around water quality tools. He's made fantastic contributions. So good to see you here, Jack.
Good to be here. Thank you.
So yeah, I do disagree with that, actually. I think that for most, look, there are certainly cases where the science is clear and you can separate the science from politics. But I think most of the things that we fight over, that's not the case, and that there's always room for introducing judgment, and there's always enough uncertainty to allow different values to battle each other. And I guess I look at the political dispute as the independent variable, not the dependent variable. I think it's a complicated world, and people have different interests, different ways of understanding the world, different ways of construing what counts as risk and how it should be understood. And I don't think I don't think there's anything resolvable about that. It has to be managed, and that's what democracy does. I think there has been a dream that science could defuse a lot of that stuff, and I think the dream is empirically falsified at this point.
There's that great quote that sort of gets rehashed and paraphrased by Harry Collins. Science, if it can deliver truth, cannot deliver it at the speed of politics. And so many of the things, as you've been saying, so many of the things that we end up fighting over are incredibly complex, emergent phenomena that we're often asking scientists to come up with sure answers to questions that, even if we had 100 or 1,000 years to try to puzzle through them, we might not get to a point of clarity or sureness about them. And so the science is then forced to sort of back itself into a corner and say, well, yes, it's this. But it turns out then the complexity sort of pops open Pandora's box. And then there's, now I'm stretching metaphors, but then there's egg on the face of the scientists, there's egg on the face of the politicians, because things aren't so cut and dry. And so, I mean, yeah, the politics has a role to play in all of this, or our politics, our decision-making as a populace together in the face of problems that don't have clear right or wrong answers, that does have a role to play. But, Dan, it's like you said, we keep looking to science to sort of be this system outside of our politics to finally tell us, do this or do that, and that's often when we've gotten into trouble.
And not only that, I want to point out that this was predicted in the early 1970s, especially by a physicist named Alvin Weinberg, who was a big advocate for nuclear energy. He ran Oak Ridge National Lab, but he was also a pretty smart and intellectually honest guy. And what he recognized was that science, in the kinds of contexts that we're talking about, really is, it ain't physics and it ain't chemistry. It's something different. He called it trans science. I guess I'm even less optimistic than Philip in that I don't think it can ever catch up to the politics. But whether or not it can is a theoretical matter. The fact of the matter is that in real time it doesn't. And so we ask much more of it than it can deliver.
I've misrepresented myself because I'm rarely cast as the optimist, so I'm actually right there with you. Yeah.
Sorry, can I think a lot of this actually has to do with a missing piece of the puzzle being risk education and statistics education. And
can we introduce you, Gretchen?
Sorry. Hi.
Hi, Gretchen. Great to have you. Can you do a short introduction?
Yeah. Hi. My name is Gretchen Gerke, and I'm the data advocacy steward on public lab staff. And
your background is in?
Right. Background, I have a PhD in geochemistry, and then I did a postdoc in environmental engineering.
Thank you.
So science background, but now I'm working primarily in more of an advocacy realm, and so learning this whole political sphere is pretty fascinating. But I really think that the missing piece of this puzzle is that all science is extremely nuanced, and that's why when you read a scientific publication, it's constant backpedaling. Everything is backpedaling, and describing the exact scientific or the exact experimental parameters, which it must, because that's the only data that's the only condition for which that data is true. And that whole lying about things that that's beside the point. That's a small portion of scientists that actually falsify their data, and it's getting caught more and more and more. And I think that's the reason for all of the retractions recently. Anyway, side point. But in order to make the transition from the detailed studies and exactly what they can say to the policy world involves a whole slew of statistics. And what we need is that statistical education and that literacy for that within the general public and within politicians who are making these decisions without any sort of background in either science or stats. So that's what I think is the missing piece of the puzzle.
The key word there, Gretchen, is the word probably. Right? I mean, when you're dealing with probabilistic science, but you're trying to base policy on it, you have to account for the word probably. There's a statistical possibility that what you predicted will happen. Whether or not even that statistical possibility is replicable or valid is a different question. But yeah, you bring up a good point. I think very often scientific results are treated as a binary. Yes, it is, or yes, it isn't. And you know, I think everything that we're discussing is still up for grabs. I think this is yet another layer of complexity in there that we forget the word probably in a lot of these cases.
And I think this is going to be an increasingly large issue as we move toward big data, which is really just big probablys and a lot of interlocution between these actual data points. And things like, it's all well and good to have these like air quality indices. You can go on the EPA and be like, oh, what's my air quality like today? It's great. Okay, good, green light. But when you look at like where actually the monitor's located, they could be 200 miles away. And so you're like, okay, can you provide me with the model information for exactly how you are, like what are your model parameters to tell me what my air quality is here when your nearest data point is 200 miles away? And that kind of information I think needs to be more readily available, and to explain more about what are those confidence intervals.
I'm probably a Harry Collins fanboy today, so I'll lend another quote of his, which is "Distance lends enchantment." And I think in a lot of those indices and a lot of those sort of benchmarking rubrics and toolkits, there's a lot of complexity that gets flattened out in order to sort of do this, to arrive at what is the meaning of life number, and all of the black boxing that happens around that. It's black boxed, and it very quickly goes from, well, we lose the conversation around all of that probably again, and it just becomes surety.
No, I want to just offer an on the fly hypothesis here, based on Jack, Gretchen, and my different disciplinary perspectives. Okay, so Jack's a chemist and Gretchen's a geochemist. Is that right? Mm-hmm. And environmental engineer, and I was a field geologist. Okay, and so Jack gets to talk about molecules, and Gretchen gets to talk about engineering models to make sure your bridges don't fall down, and I get to talk about a billion-year narrative of a field area. And the point I want to make is that each of us has a different relationship to certainty, to uncertainty, and to thinking about how our understanding of, say, science through our perspectives relates to the human world. And what I want to try to get at is, Gretchen, I don't think all the statistical sophistication in the world equally spread among all people would make any difference. And I think the reason is there's too many ways to legitimately understand the world that are not necessarily commensurable, right? Mm-hmm. And so yes, it would be great if everybody were literate in lots of things. And it would be especially great if people weren't dumb about obvious things. But I kind of think that's rarely the problem. One of the things I learned really fast working on the Hill was that people whose positions I found, offensive or execrable, were like smart and nice, and God knows how they could disagree with me. And they did so because they just had this. They just had a different way of combining the facts that they thought mattered with their model of how social change should occur and what the world ought to look like. And I'm I just don't think there's an optimization function around that. I mean, to me, the dilemma is we know stuff, we know a lot of stuff, and we don't know a lot of stuff, and then there's the in-between, and kind of how do you mix and match that to come up with something that allows you to take a step? And one of the things I think is so cool about sort of focusing on the local is that's where you can kind of create a somewhat homogeneous set of values around something like what you want your community to look like and what are the things you're trying to achieve there. And so then, like, you don't argue so much about the facts because you can find the facts that work for everybody and it's fine. But then you bring in the community next door, and for them, employment at that factory that's polluting your community is a big deal, and so suddenly the facts become different and construed differently. I think the more everyone knows about everything, sure, that's a great value. But I think it's more like we have to figure out how to live with each other, and how to make the best claims we can make about how the world works, but recognizing that those claims are always contextual and always value-laden.
I mean, I'd agree.
Which is
isn't the point of things like science that are supposed to be impartial, that you can bridge those ideological gaps? Otherwise, we'll just be like contained in these little silos of homogeneous populations and never learn to play with one another. Like, isn't that the point of it? Like, of science?
I would argue no. I think the point of science is to create truths that withstand a lot of testing, and then when it's revealed that they don't quite live up to whatever testing they've been put through, some other perspective or explanation of how the world works is put forward. And I actually think we run into a lot of trouble when we expect that kind of bridge building of science, because time and time again it's shown that it can't do that. And here we are right now. I mean, the proof is in the pudding. There's plenty of science about any number of topics that many people disagree about, many smart people disagree about. So, and many foolish people disagree about as well, to your earlier point. I think, Dan, you're expressing a really pragmatist point of view about sort of the epistemology of what we're trying to, what kind of knowledge we're getting at. I mean, and when we think of it at the local level, I think we start to lose the imperative to create knowledge, and specifically using knowledge as opposed to science, to create knowledge for science rather than creating knowledge for decision making, either sort of in a policy way or in a day-to-day. I work with a lot of community gardeners. Are we going to plant the tomatoes under a tree, or are we going to plant them out in the sun? Well, it didn't work under the tree last year. We'll do it out in the sun. It's a form of knowledge making, but it doesn't necessarily rise to what we expect of capital S science. But it's at the local level and allows us to sort of to sort of step back from the I guess the high stakes that we expect from knowledge making in science. Dan, I appreciate that you keep bringing it back to the local.
No, this is a great point, because so there's a couple things going on here too, which is we're using science like as this one. We all know that there's no science,
right?
Unless you want to study physics,
right?
There's science that can say. I mean, I think we also know, Gretchen, that the science that can say the biggest, most universal things is the least applicable to the local context.
Mm-hmm.
And so maybe part of the problem too is there's a struggle between kinds of knowledge here, right? So we can't really get away still from the idea that if only all the other sciences would grow up, they'd end up looking like physics. But I think that's been also empirically falsified at this point. And some sciences do get closer to a physics model. Some try to and fail, like economics, I would say. And others, like anthropology, haven't really tried. So maybe maybe part of what you're saying, Phil, too, is we have to have a more cosmopolitan or pluralistic sense of what science is and what knowledge is, and that can allow us to accept that science has science in its kind of Empyrean mode has great strengths for doing particular things. For example, allowing technological innovation. But other kinds of sciences have great strengths, not for making generalizable laws, but for allowing us to understand, how how to best plant tomatoes or how to manage complex political disagreements.
Yeah, I'd like to say that, I think one thing science is good at is arriving at, fundamental truths. So something like the effect of mercury on childhood development is pretty well established, and that's something that has to inform public policy about burning coal and the effect that that has on downstream airborne mercury and whether that's going to end up in children's food and stuff like this. So I'm not convinced that everything has to be local. I think everybody has to accept certain number of fundamental facts, and that science does have the job of providing those facts. And it's a political thing that says, oh, it's cheaper for us to burn coal and not scrub out the mercury out of the effluent, and that's good for the stockholders. That's a political decision. That's not something you have a choice about accepting or not.
What do you mean? Can you just clarify your last point that you don't have a choice about accepting or not?
I don't think you have the choice. I don't think you have the choice of accepting or not accepting that burning huge amounts of coal has a negative impact on the people downstream from the power plant.
Right, but that fact coexists with other facts about how very difficult it is to transform economic dependence around certain industries that lots of interest, not just stockholders. It's easy to make fun of rich people, but also coal miners don't like losing their jobs either. And but I mean, to the point that there's certain things we know. Yeah, of course there's certain things we know, and there's also lots of things we don't know. There's, as you know better than I, there's something like 8,000 or 9,000 uncharacterized chemicals that are now in the environment that we simply, can't really say very much about. I mean, mercury is a nice example of something where there's a fairly uncontested fact, and it's still in a very complex, contested environment that I agree is largely political. But I don't dismiss political. I mean, political is, that's how we resolve disputes without killing each other. But I also think the mercury example is probably, atypical. That many more of the things we fight about, there really are also uncertainties about what to do and what the actions of them, what actions we ought to take. I mean, great examples that are a little less politicized, but that there are now terrible debates around are things like mammography, or this great article yesterday in the Post about saturated fats, Washington Post about saturated fats, and the possibility that actually drinking low-fat milk has led to declines in cardiovascular health rather than improvement. I mean, it's really unbelievable, right? So the places where in a complex problem science has something totally definitive to say, I think are not that common. But I don't want to at all disagree that even when science can say something definitive, it doesn't mean that the politics follows suit. It certainly does not. Or follows along.
There's a classic case that mimics the idea of mercury exposure, and I think exposure is actually where the complexity comes in, not in the whether or not mercury exposure is toxic. Again, it comes down to the local case, the specific case that has to deal with all the complexities of exposure in some particular type of effluent, how severe the exposure was, how prolonged the exposure was, etc. We probably can't debate the toxicity of exposure to nuclear fallout, but there's a really insightful case from Britain after the Chernobyl incident with sheep farmers. It's a classic in science and technology studies where, again, no one really would dispute that the fallout that happened in the Highlands in a particular community in Britain was potentially toxic to livestock that was in that area. But then the complexity of how the fallout was absorbed into the soil, how then it was absorbed into the grasses that were eaten by sheep in that area, the grazing patterns, the methods that scientists use to sample and ultimately try to pen sheep, which if you're a shepherd, you don't pen sheep. That's sort of part of the realization. So anyway, I'm sort of doing a hash job of recounting this case, but the point is that the complexity came in the actual local case, not in what we knew about the dangers of exposure. So, and scientists were marshaled, mainly physicists were marshaled to prove the safety of lamb's meat, consuming lamb's meat and sheep meat after that incident, and found themselves unable to do so, or at least publishing results that weren't necessarily true because they weren't accounting for a number of complexities. Interestingly, I think expertise falls into this conversation in that particular case because a number of sheep farmers were watching the way these scientists were taking samples of sheep population, of grazing sheep population, and kept saying, you're doing it wrong, you're doing it wrong, you're not actually accounting for how sheep move through this landscape, you're not actually taking stock of the reality that we know. And the scientists basically kept telling them to just back off. So in addition to considering different kinds of knowledge, also considering different kinds of expertise, which is sort of the two sides of the same coin.
Well, I think that fits in really nicely with when we were circling around the idea of local earlier. Locally held values and local forms of expertise and local fluency in one's environment. And in many cases, that we're seeing in community science, people are going out and doing research to better understand their own local environments and then to be better advocates. So I know we've been, we've gone very far in the discussion between, what is known by science and how that doesn't in any way exempt the issues around value choices. But I have to also just get very pragmatic and straightforward and just say that, people are out learning about their local environments so that they can better advocate for themselves. And I don't hear, yes, that issue kind of falls apart when we get to a federal and a policy level. But I just wonder, since Daniel opened with kind of one of his statements was that if grassroots organizations who are doing environmental advocacy are pinning their legitimacy on science, where does that leave? And there's all these contested issues. Where does that leave them? And I just want to get back and say that we never really upended the local relevance of and local knowledge and local expertise here. That's the context for most of the research I see going on. And I wonder if anyone has something to say about that.
So is your question about how to, where the legitimacy for such knowledge should come from? Is that what you're trying to get at?
I guess I was defending people who are going out with either established or DIY tools to improve what they know about their local environments. Yep. Because that, in an age of, where you're given value position has to be entered into political discourse, and when political discourse is being dominated by data, the bigger the better, there's an important role for doing one's own environmental research to go and being able to talk that language of power. So I guess I was just trying to raise a flag saying that when we get to the big levels of policy, there's lots of facts coexisting in the presence of other facts, but I don't think we've really torn down the idea of people doing their, advocating for their own locally held environmental goals. through doing their own environmental research?
No, on the contrary. I think what I understand the momenta of the conversation, at least in my position, it may not be Jack and Gretchen, is that if we talk about some, so this is, so here's the thing I'm going to say I wish more people knew, right? Which is always the kind of last resort that we all have. I wish more people understood the pluralism and diversity of science, and how certain, and the importance of context and understanding, and the value of local knowledge and expertise and craft skill and so on. And if they did understand and have that, maybe everyone should be reading Life on the Mississippi or something. So I mean, just some great narrative that really explains craft skill beautifully, and tacit knowledge. I think that if local expertise, to bring that word into things, was as legitimate as it ought to be, then it would compete for status in policy debates with other types of expertise. And in a sense, I guess, as a practical matter, it does, of course, because you go to any congressional hearing and there's always someone from the chairman's district talking about whatever happened to them. But nonetheless, it seems like the dilemma, Liz, right, is that on the one hand there are these difficulties with imperial science, and I think the kind of alternative that Phil and I are talking about are one that would assign or attribute legitimacy to multiple sources of knowledge. I mean, isn't that maybe the best route to addressing your concern there? Is how do we create a space for the kind of knowledge that people who can figure out how to solve problems at the local scale actually have acquired?
Maybe if there was enough local going on, all the locals could get together and drive these bigger decisions. Because honestly, like I'm afraid of an environmental regulatory landscape where science has been stripped of its, capital S science has been stripped of its legitimacy, and it's no longer imperial science, and all we have left is imperial money and power.
Yeah. But that's
on.
That the science tells us we have to do this, when what we really mean is that the weight of evidence as we interpret it, plus our belief about what a better world ought to look like, tells us that we ought to do this. And that's the conversation that you're not allowed to have, right? Because that undermines what we have insisted is the determinative role of science in these discussions.
I always think about some of the work I did with a group trying to get rid of a highway in the South Bronx that had been plowed through in the 50s through an otherwise functional neighborhood. And it was 4 or 5 different community groups that had come together to call on the State Department of Transportation to tear down this highway that was essentially underused and was blocking access to a number of park amenities and other amenities. And folks in the neighborhood would get sort of organized to show up to public hearings where the transportation engineers would hear public comment on the pros and cons of different engineering decisions about taking down this highway. And they would hold up signs that said, "We are experts too," and then proceed to offer public testimony that really had to do with their day-to-day lives. And I think what got muddied up in that conversation was what they meant to say was, we're experts in living here. We're not experts, we're not transit experts, we're not transportation engineering experts like the ones sitting at the table on the dais taking testimony, but we're experts in living here, and we have important data to contribute to your decision making as well. But the model that the engineers were able to follow was only the model of their engineering expertise and not of any other kinds of knowledge or expertise in that decision making, because we said that that science was going to tell us precisely how to go about decision making. In this case, around the sort of the science of transportation engineering would tell us precisely the most efficient decision to make about turning down this highway. And I always wish that we had sort of clarified what those signs, those placards that people had up said, instead of just saying we're experts too, which I think the decision makers could easily brush off as being untrue. But if they had said we're experts in living here, I think they might have listened a bit more.
Can I just add to that? I think that's a great example, and it puts me in mind of another one, which is, and one can be smart or not smart about politics too, right? And so I will assert, and this may or may not be right, but that the say the Tosca approach for regulating chemicals is just a failure. And we need, and it's a scientific and political failure, and we need another approach. And I think part of that's a matter of smart politics. So I have something in mind in this regard, which is my heroes at the University of Massachusetts Lowell and the Toxic Use Reduction Institute there. And this is just a different way to think about regulating toxic chemicals. And it's not one based on scientific proof. It's one based on accepting significant uncertainties in the epidemiology of toxicity of lots of chemicals, of looking at the weight of evidence, and then working with interested stakeholders to find alternatives. And it's supported by a piece of legislation, and it's supported by the kind of research enterprise at this university that can't exist in most universities because it doesn't generate lots of publications. And it requires requires employees who spend a lot of time doing outreach rather than publishing papers. So it's a kind of unique institutional setting as well. And so the point I want to make is that there's lots of space for innovation in politics, in science, and in institutions for dealing with these problems. We're stuck with a particular model that may have worked in the late 60s and early 70s when when rivers were catching on fire. But we have a more complicated and nuanced problem now that I think has shown that the politics and the institutions and the science are not, they're not being appropriately used. So I don't give up at all on science for this. I just think we need to be smarter about it, about the politics, and about the institutional settings.
I would agree with you that the focus on publishing papers is way overblown in our academic society. All right, so I think there are things that we could be doing that would help society that we're not doing because of the way the incentive structure of academics is set up. And I'm kind of working on that myself at my university, and I think the people on this conference call are probably all doing the same things that I'm doing, and I suspect we're in for change, but I think it'll not be in my lifetime,
I appreciate this call to academic science because as an academic, but not in the sciences, and as an environmentalist, it definitely seems like institutional science has really abdicated its role in taking care of the environment because it's so inward-looking, and that's the space that the civil sector is moving into, with a lot of these nonprofit and citizen action groups that I'm involved with.
Yeah, I'd like to address something that Dan said about pluralism, diversity, and context being needed, and I would totally agree with that. And I think that things that like Public Lab does to empower people to monitor their own environment, that breeds pluralism and diversity of opinions, and it makes people in those places understand the difficulties of doing science. And I think if more people understood the difficulties, they'd understand the context and the subtleties of getting science done. And so, I'm very happy to be part of this, and I think it's got a great educational mission as well as direct environmental benefit.
Agreed.
Well, we are just a couple minutes from the top of the hour, so we're getting ready to wrap the call, but if anyone has any last comments, please bring them up.
I think it's been a great conversation, and in some ways an object lesson in the very challenges that we're trying to address. Right?
That's great.
Agreed.
I'm in Durham, North Carolina. I didn't know that you were also in this.
Oh, you're in Durham?
Yeah.
Yeah, I was there Monday.
Oh, nice.
Yeah, thank you, Gretchen, Jack, Philip, and Daniel. I really appreciate this. There's also a handful of other people watching online. It'd be great to hear any follow-up questions from you guys online by writing into the public lab mailing lists, and we'll see if we can't get Daniel and Phil in there to keep the discussion going. Yeah, just thank you, everybody. And the next time we'll be live doing a public lab hangout is going to be on the first Monday of November at our next official open hour. And see you guys then. Thank you.
Thanks, Liz.
Everybody. Nice to meet you all.
Nice to meet you.